After months of preparation, our 480-ton crawler crane gently placed the first section of the pedestrian footbridge at the new Loganlea station. But hold on, it wasn't that simple. And before we got to this, and this, Borger's teams had put in months of work. It all started back at Brisbane Yard. Lorena sat down and started working it out. She did the drafts, she clicked, she tried things, again, and again, and again, and slowly, it started to take shape. She figured out which crane to use, where to position it, how to pick up the load and set it down. Heaps more calculations. Then came the scheduling. Not easy. We weren't the only ones on site. We pulled together a dream team. The crane came in pieces. Lots of trucks. Lots of time. It was crucial to be extremely precise. Then the crane went up, and it was meetings. Tests, discussions, trial runs, measurements, checks, adjustments, and more meetings. Tests, discussions, trial runs, measurements, checks, adjustments. And then, one day, we were ready. And all that led to this stunning view. And now we are going to tell you how the project was Borgerized.
So, when we received the tender from this client, they explained us that they needed to install a concourse model as part of the Loganlea station relocation. And they explained to us what it needed to get done and what were the site constraints. So in here we can see what is the rigging arrangement and how the concourse needs to be lifted in a safe way. And it gives us dimensions and an estimation of how big it is. So based on that, we can start doing this kind of preliminary sketch. We started to show the client what it was possible to do with our 480-ton Sunny crawler. One major thing is that we have a very, very tight space here to put the load to be picked up. That means that we can only pick it in one direction and then slew towards the final position in a very specific way. When you're doing this kind of job, you have to understand how the crane works. If you are driving it, how it will look? How it will look for the people that are outside? What are my constraints in regards to the side? How am I planning from pickup to final placement? You definitely have to imagine how it's going to be.
Overall, forecast is for mostly sunny. And as we said, we have the crane up there with the Borgers, we've got a 40-ton crane, work's going on, assembly, Borgers got a 230-ton crane, is already on site, and they've got 8 seconds coming in to handle that work. Not yet, shot bricks for bricks. And that is
This was the inaugural project for the second of our new 480-ton Sani crawler cranes after arrival into Australia at the beginning of January 2026. Only a few weeks later, the crane was mobilised into the project at Loganlea Station for Martinez-Degnan joint venture. The crane was selected specifically for its capacity and variable superlift configurations to safely position a 122.7-tonne concourse at a 33-metre radius. Assembly took place in the week prior to the lift, using Borger Cranes heavy haulage trailers and semi-trailer fleet to deliver all crane components, superlift counterweights, support and lifting equipment, all coordinated through a detailed transport and mobilisation plan that sequenced truck arrivals with each step of the build. During site establishment and lifting operations, the team had to manage additional site constraints and maintain at least 6 metres of setback from the new retaining wall to adhere to allowable loading constraints, all while coordinating closely with other trades to maintain site productivity. This was choreographed by careful planning and executed by our experienced heavy lift team to achieve a safe and incident-free lift.
So there's a few advantages of this crane. First of all, it's got the super lift capacity. So once we connect the super lift, we achieve significantly higher capacities than a crane with no derrick and super lift, as well as any telescopic crane. In addition to this, it's a crane that is still easy to transport, so the cost of mobilization and demobilizations are not significant. And from the technical side as well, the crawlers are placed in a position where we can actually distribute the load as optimized as possible towards the side of the rail.
Tell me how you feel, is it real? I don't wanna overthink. Is it all for show? I don't know, feeling like a mind. That's something beautiful.
Video, guys.
I know I
Car park
shouldn't
prep,
ask
lift
you to
set up,
be open with me
demoting is
when
happening at, and there's a lot of
my
trucks coming in,
secrets
and also the front.
tend to keep
2 bottom trucks working today, to be confirmed. Silver Strand,
I'm
got a flatbed coming in for the demo, and we've got Brownie
at least I know we could
As always, ladies and gentlemen, man, that's always a pleasure. And we'll walk off behind each other.
Tell me how you feel. Is it real? I don't wanna over.
The main technical challenge was the load itself, a unique, non-symmetrical concourse that required complex centre of gravity calculations and carefully engineered rigging so the load would lift level, pass cleanly around a lift shaft and be lowered precisely onto its bearings in its final position.
Ask you to be open with me when
We are gonna
my secrets
measure the load on each of the lifting points. We have 8 in total, so we got 8 load cells. If we lift it and it's unleveled, then we will use that data to try to estimate the center of gravity and be able to change the rigging to get it as level as possible.
only one way to know. Only one way to know. Is this a yes or a no? Which way will it go?
So these are all the load cells. This is our total load.
Only one
Let's
way
go,
to
Sergio.
know.
You can see Sergio over there. Yep. Yep. Yes, yes I can.
Only one way to know.
Yeah, they're all asleep. Turning on now. Age 719 and age, okay, age 719. Oh, they're on. See that all of them are working. What we're doing now is starting to check if the load cells are on, and they're logging the data. That will help us to calculate where the center of the gravity of the structure is. The diagram of the shape of the load, and I'm marking where our load cells are and how they're named.
So some of the complexities of this lift is that the center of gravity has some sort of uncertainty. If we are very far away from the theoretical value, then we'll be able to adjust the rigging. Some of the other complexities are the lifting points were not placed on equidistant positions. So we have to come with a clever idea to get around different spreader sizes and compensating for sling lengths. As you can see, all the triangles are not equilateral.
Maybe leak could come out. That's probably the only potentially spare.
That's 50 ton.
Yep. So these ones are each of the load cells that we have placed in the structure, and this is our total. So we have an accurate reading of how heavy the load is on the hook right now. So based on where they are and the load that they're carrying, we can now then calculate where the COG of the structure is. 95 ton, almost 100 over here.
100 ton.
103.
Oh, here we go.
106.
5.7.
107.5.
So the COG is roughly where we said it was. I think the engineer will be happy. So with the COG, we're not too far off. Slightly. Oh, right, okay.
It's slightly on the y-axis.
On the y-axis?
Yeah.
Okay.
161. It's all good. It's looking good. One 109. Let's see. Okay, now just analyzing the data of each. Then in here we can see the difference between what it was estimated, and in here in this yellow we can see the actual. Our calculations were very accurate.
The module weighs around 120 tons. So what we are planning right now is to lift the module without the super lift. Then we will slew around. Once we have slewed for 90 degrees, the crane will connect the super lift on its back, on the frame. And once we've got that extra capacity from the super lift, we will be able to boom down to the maximum radius. Once we've done that, we'll slew approximately 45 more degrees, and then we'll start landing the module onto its final position. Something that is important about this lift is that the lift core is built already and will go inside the module. So there are very tight tolerances, and we'll need to do a very slow lowering of the module. and a lot of planning has been done so that we can actually achieve this.
Morning everyone, Borger's here. This is what the structure sort of looks like. This is just a model. So you've got the structural steel, you've got some timber flooring, you've got the holding edge protection, and you've got some handrail up on the roof. We slung it yesterday, and we're gonna start lifting. We're gonna pick it up, go anti-clockwise towards the station building, up to the station building. We'll have traffic control stopping traffic. So we'll slew over the lift shaft. The boys will use the tag lines to try and stabilize the structure on top of the lift shaft. Once they're happy, we have very tight tolerances, 30-40 mil just around the lift shaft and the steel opening, and then we'll start dropping the load. Once it's in, I think it'll be sort of a lot easier sort of to guide it and drop it.
How's that look? So we're here about to finalize the lift. At the moment, we have already touched the pop bearings, but we need to gradually release the load onto them so that we are not overloading them. The design of the rigging arrangement that we have used allows us to shift the load in between the pop bearings as they start touching one another. You can see the tight clearances that we manage. So we allow our clients to install the most amount of steel around the structures that we are lifting. The biggest complication is that you have the lift core in the middle, which is encapsulated around the steel structure. So you don't have a lot of tolerance, a lot of movement. We were able to plan this in advance so that everything went according to our plan and we didn't have to remove, cut, or uninstall any of the members that the client had previously put already.
Months of preparation, engineering meetings, design reviews, reports, and on Saturday morning it all came together, with the lift completed in just a few hours. There is still a lot of work to be done before we reach this stage, and Borger Cranes is pleased to be a part of this incredible project. In fact, even while the first section of the footbridge was being installed, our teams were already preparing for the next phase to ensure that the station is completed on schedule. For us, the work doesn't stop there. The day after the lift, our teams began the demobilization process to remove the crane and clear the site for other trades to continue the construction.